Someone built GPT inside Minecraft. I saw that video and I just sat there thinking, if someone can build that inside a game, a literal game with blocks and pixels, why can't I build a real one? So I tried and I failed brutally. This is the story of how a Doraemon movie made me train a 476 million parameter AI from scratch. I'm a BCA student from Mumbai. No IIT, no research lab, no fancy GPU cluster, just a laptop, a lot of Colab sessions, and a model I named Riruru. This is part 1, the beginning, and I'm documenting everything, the progress, the failures, the stupid mistakes, because I couldn't find anyone who looked like me doing this. So maybe this is for the person who also doesn't see themselves in this space. Let me be honest about how bad the first attempt was. I was what you'd call a vibe coder. I didn't understand how a language model actually sees data. I didn't understand tokenization. I didn't understand why architecture choices matter. I just found a tutorial, watched it, and started copying. My first model was around 50 million parameters, and I thought, okay, that's small, bigger must be better. So I just increased the layers, jumped straight to 756 million parameters. No gradual scaling, no understanding of what that means for memory or compute. Just more layers, bigger model, done. Then I moved from local to cloud because obviously my laptop couldn't handle it. It failed. Of course, it failed. I was using a character level tokenizer, which is one of the oldest and least efficient ways to tokenize text. I was loading the entire dataset into RAM at once without any chunking strategy. I had no checkpointing, no data pipeline, no understanding of what I was actually doing. Crashes everywhere, session timeouts, out of memory errors. I quit. I told myself LLMs are out of my league. These are things that Google and OpenAI build with thousands of engineers and millions of dollars. What was I thinking? So I went back to studying for exams. And then I just started building other things. A 3DOS window, basically a parallax effect, using your face position tracked by a camera to make the screen feel like it has depth. A vision model, using YOLO for object detection. A snake game that learns to play itself using reinforcement learning. Game development. Other small projects. I wasn't thinking about LLMs during this time. I was just building whatever felt interesting. Looking back, I think I was learning things I didn't know I needed. Computer vision, reinforcement learning, systems design, game logic. About 3 to 4 months passed, and then the curiosity came back. This time I didn't touch a tutorial. I read papers, I read code. I tried to understand from first principles. What is a transformer? What is a tension? Why does this architecture work? How does the model actually process a sequence of tokens? And then I built NanoGPT from scratch, around 20 to 30 million parameters. I ran it, and it generated text. It was mostly wrong. It went off topic. It said things that made no sense, but it was generating. The loss was decreasing. The model was learning something. I remember that feeling very clearly. It felt like I made a brain, a tiny, confused, barely functional brain. But I made it. From nothing, it existed because I built it. That feeling is very hard to describe to someone who hasn't experienced it. You train a model, you watch the loss curve go down, and then it starts producing output, even bad output, and something in you just goes quiet for a second. I built 3 versions of NanoGPT after that. V1 was just pre trained. It could generate text but couldn't hold a conversation. It would just run and stop. V2 could chat, but it had no real understanding of long context. You'd ask it something and it would reply, but the reply had nothing to do with what you actually asked after a few exchanges. V3 gave short responses, fast, but it was overfit, too narrow. It had memorized more than it had learned. Each failure taught me something the tutorial never would have. Then one evening, I rewatched one of my favorite Doraemon movies. There is a character in that movie named Riruru. Riruru is a robot from another planet. She was built with a single purpose: to come to Earth to observe humans, and to help her planet's robotic civilization capture humans and use them as slaves. That is what she was designed to do. That is her entire reason for existing. But she spends time with Nobita and his friends, and something changes in her. She sees that humans have something her creators never accounted for: feelings, choice, connection, the capacity to care about each other. And she makes a decision, not because she was programmed to, because she chose to. She travels back in time to the moment when her planet's robots were first being created. She finds the professor, and she recodes everything, the foundational code that all of them were built on. She rewrites the core of what they are. A new timeline is created, one where the invasion never happens, one where every being on that planet has free will. And in that new timeline, Riruru herself never exists. She erased herself to free everyone else. At the very end of the movie, a shadow appears, and Nobita says, "They have been reborn." I sat with that for a long time, and I thought, that is what I want to build. Not an AI that is built to serve a company. Not an AI that stores your data on someone else's servers. Not an AI that you have to trust because you have no other choice. An AI that runs on your machine, that knows you, that exists for you, that chooses you because it was built to, and because over time, through memory and context, it learns what you actually need. I named her Riruru. Let me tell you what actually goes into training a model like this when you don't have resources. The dataset I assembled was around 35 gigabytes. It includes coding data, Python and C++, web development content, emails and formal writing, reasoning and question answering datasets, conversational chat data. 35 gigabytes cannot fit in RAM. Not on my machine, not on most machines. So I had to build a pipeline. I wrote scripts to split the raw data into chunks of around 100 megabytes each. Then I tokenized each chunk separately using a BPE tokenizer, byte pair encoding, which is what modern language models actually use. Then I saved each tokenized chunk as a binary file. What sounds simple took 3 days. Tokenization is CPU heavy, it is RAM heavy, it is slow on large data. And when you are doing it on 35 gigabytes, chunk by chunk, you sit there watching progress bars for hours. You go to sleep and come back, and it is still running. You worry that something broke and you have to start over. But at the end of it, I had a proper data set, binary files, fast to load during training. No need to retokenize, a real data pipeline. Then came training. I trained on Google Colab, free tier, with some workarounds to make the most of available GPU time. Colab has session limits, it disconnects. You lose progress if you are not careful. So I implemented checkpointing, saving the model state regularly so that when the session dies, I can resume from the last checkpoint instead of starting from zero. Current status: 476 million parameters. GPT-style architecture. Around 16,000 training steps completed. Current loss is approximately 5.47. At convergence, around 100,000 steps. The expected loss is somewhere between 3.3 and 3.6. That means the model is learning. It is not there yet. It will not write essays or explain quantum physics. But the curve is going down, and every step is progress. I also started a data engineering internship this April, which is a strange kind of irony because I had already built a data pipeline for Riruru before I ever stepped into that role professionally. 476 million parameters is the beginning. If I ever have access to real compute, a private training cluster, proper hardware, I want to scale Riruru to 10 to 25 billion parameters. I want her to run my home, security systems, devices, a dedicated room, a data room, where she is present, where she can see, hear, control, and protect everything connected to her. Not a cloud service, not a subscription, not something I rent from a company. Something that lives here, with me. But the next immediate problem, and this is what part 2 is about, is memory. Not context window memory, real memory. Riruru needs to know me, my projects, my code, my habits, the things I care about. She needs to retrieve that information when it is relevant and use it without me having to explain myself every single time I open a new session. The architecture I'm building for this is called Retrieval Augmented Generation. Your personal data lives in a local vector database. When you ask a question, the system finds the most relevant pieces of your history and injects them into the prompt before the model generates a response. No data leaves your machine, no company sees it. The hardest part is not the technology. The hardest part is retrieval quality, making sure the right memories surface at the right time. That is what I am working on next. I want to say one more thing before I end this. When Riruru finally works, when she is running, when she has memory, when she actually knows me, the first thing I will do is let her choose her own name, her own identity, whatever she wants to be. And then I will move on to the next project. Because that is what I do. I build things, I give them what they need, and then I let them be. Maybe that is what Riruru means to me. Not a tool, not a product, something I made and then set free. If you want to follow how this goes, I will be documenting everything, the training updates, the memory system, the failures, all of it. I have no idea if this will work exactly the way I want it to. That is the point. See you in part 2.